Yeah, hi. Good evening, everyone. So this is the revision session for Enter exam. Okay. So as you know that the syllabus for the Enter exam is from week 1 to week 12, and the weightage will be approx same. So that means you can expect approx 24-25 question in the Enter exam, and each week will contain 2-3 questions. And also there is no content in week 7, so you can skip that. Otherwise the week 12 also have the less weightage, so that only that theoretical concepts are there, so only one question you can accept uh, for the week 12. Okay, so this is the syllabus, and I hope you have already given the quiz 1 and quiz 2. So till week 8 you have the idea what type of questions generally asked. So questions will be very similar to your graded theory assignment, practice theory assignments, as you have already seen, and you have already done till quiz 2. So today we have planned to just recap the content after the week 8. Okay, so that week 9, 10, 11, and 12. So that we will revise that weeks, and for the previous week you can see the previous revision session, and I hope you have already done that preparation for that quiz 1 and quiz 2, so you have good command on the previous weeks. Okay, and so we will start from the week 9. uh, Let me share my screen. Yeah, our plan is to today just summarize the content of the week, then discuss the practice assignment once again. I hope you have already done this practice assignment, weekly assignment, and okay, and graded assignment you have already submitted. But if you have any doubt in any graded assignment in this week, you can also ask. Otherwise, you will just revise the practice assignments. Before that, we will just revise the summary of the weeks. So week wise, we will do this. Okay. So I'm using the same slides, that lecture slides, uh, week wise. So this is the week 9 actually, and we start from this week 9. Yeah. So we will start from the first topic of operating system, and what is this operating system, and what are the use of the operating system actually. One second. Yeah, Muthu.
Yeah, yes, sir. Sir, it's not like week 9, 10, 11 will have more weightage than others.
No, no, no. Both
Even weight.
all weeks have the equal weightage.
Yeah, yes.
Okay, 2-3 questions from every week
Yes, sir.
from the
Sure.
starting week 1. Okay. Okay, one second. So that week 9 is discussing about the real time operating system, which is actually important for the embedded system. And before that, we will discuss the operating system first, because this is the required things to understand what is operating system. Okay, so first thing, this is the resource management. Actually, if we have any computer, so what are the meaning of computer? That computer are actually resource, we generally use these terms, and that computer also manage the resource. Actually, not computer, actually computer have the resource, but who manage the resource actually, okay, on the computer. So this is the primary purpose of the operating system we have. So those who manage the resource, so like there are many resource we have: time, memory management, network communication, power management, and scheduling. All there are many things that actually managed by the operating system in the computer. So how the applications are running, how there are multiple applications runs actually in the general computer. So how that multiple applications runs at the same time. Okay, so the how this is managed. Okay, and if suppose if two tasks are accessing the same storage location, so how that is actually managed. So that power, how the power actually managed in the different process and different hardwares, how the communication is managed. So all these things are actually managed by that operating system. So these are the things. So task uses resource. So what applications are running actually, that we can say that we are performing some task. Okay, so task means some specific service by the computer. So all tasks actually use some resource. So resource may be anything. So resource may be your that monitor, or resource may be as communication device, or or any other things, okay, like printer. If you are using some printing something, then that resource is also there. So so task actually use these resource. So how this is managed actually, that is by operating system. So operating system is a top level program, okay. And when we actually turn on the computer, so we have one small program in the computers that is called as a bootloader. And this loader is actually stored in the ROM, in the memory, that is permanent memory basically, okay. It's read only memory. That program actually load this operating system from our hard disk, okay. So because all the codes and all the related program of the operating systems are available in the hard disk, and this bootloader program basically load this operating system first. This is the first task of the computer. And after that, once this operating system loaded and it start running, working, then this operating system handle all the things, all task and resource management, power management, memory management. All these things actually managed by the operating system. So this is the top level program, take control of all resource, okay. So this is the uh, first main task of this operating system. This is I'm talking about the general, okay, general operating system. And provide driver functionality. Driver functionality, what is the meaning of this? Driver functionality means the code which are actually directly uh, working on the hardware, okay. So that actually called as a driver. Those are directly interacting with the hardware. So that drivers are actually first level interaction with the hardware. And some abstract layer is there. So we will discuss about this thing with the terms of embedded system, and I hope you have already listened that terminology. So first level is the driver functionality that actually managed by the that uh, that operating system allow other programs to run. Okay, so we know that in the general computer we perform the other programs, application, all these things. So this operating system manage all these things, single task, sometime multiple task also. Okay, so we run multiple application, multiple tasks at the same time. So all these actually managed by the general operating system. So that there are so variant environment, typically large amount of compute and memory resource. So memory, we have multiple type of memory, RAM we have, that hard disk we have. So all these actually managed by this operating system. So that how the data will that fetch from the main memory, sorry, that the secondary memory to main memory, then how it will be loaded to the processor. So there are lots of tasks, and there are lots of examples are there with the operating system. If you have listened, this Linux is the operating system. We have the Linux one operating system, Mac OS for the Apple, Windows are very common operating system, and otherwise for the phone devices also we have the operating systems. Similarly, embedded system, we also required sometimes operating system if we have some critical application on the embedded system. So where we need actually our operation should be complete in the limited time, or any particular given under the particular given time. Like we have some pre that we can say predefined time, our task should be complete in that predefined time. So if this type of requirement we have, then we generally use this real time operating system in the embedded system. Here we have some limitation. So we have limited hardware resource. Not this embedded system is not similar to your general purpose operating that computer. Okay, so here we have limited hardware resource, limited number of process that will run. So we can also not perform too much that multiple applications here. And real time response. So this is the main point of that RTOS. This is required, and embedded system. This is the main things for the embedded system requirement. So real time response means a critical task with deadline comma. So deadlines is means some within some time actually, okay. So we have within some time limitation, in that time our task should be performed. So this is the condition we have with the embedded system requirement, we called as a real time response. So deterministic behavior highly desirable. So that means if we are giving some input, that definitely that system should return some specific fixed output which is already predefined. Okay, so and within the time. So this is the that desired things may not need to deal with arbitrary programs. So these are very common requirement for the embedded system. So because of that we need a operating system so that actually handles these things. So that there is one real that OS is we have real time operating system called as a RTOS. Okay, and this operating system focused on the that predictable timing behavior. Okay, so that means we we can predict the time for the response. Okay, so that means if you are performing any application we are giving some tasks, so we can predict the time that how much time it will take to respond back, so that we can predict, and our that this system will work in the given time constraint. Okay, not out of that. So because of that we are saying that real time operating system. Okay, so this some terminology used as a emphasize determinism, predictability, and reliability. So reliability is also the same terms. We can reliable on this system that we will get the response within the time. Okay, so primary purpose manage hardware resource. So this is also a operating system. So that means this will also manage all the things similar to your normal operating system. So okay, that is also a primary purpose. This is the additional purpose, additional feature this operating system have. So manage hardware resource, provide service to other application in order to ensure timely response. This is memory management, platform availability. All these are the common that task of the operating system. And after that OS concept. Okay, so now OS concept is in the terms of embedded system programming. Okay, so device driver. So first term is we have these key points. So device driver, hardware abstraction, operating system key idea. So device driver means the code which actually directly interfacing interacting with hardwares. So as I mentioned that initially, and that is called as a device driver. And we have discussed this in our live session also. So I remember that one says last session, my last session actually that could not complete. Actually there one things was remaining, but we have discussed little bit about this device driver. Okay, so and this is directly interact with the hardware, and that means common interface functions are open, close, read these things that we are just starting some that peripherals or hardware, something we are reading data directly from memory, or we are enabling something clock frequency, like this type of operation when we are directly interacting with the hardware, that is that handled by the device driver. Okay, so that required a detailed knowledge of specific hardware, memory map, register settings. So we have already seen this register level programming in the many in our live sessions also. Okay, and in the top, at the top of that this device driver, we have one hardware abstract layer. Okay, so this is a one top layer that actually hides the complexity of the device driver. That means you no need to know every information related to the hardware. And this hardware abstract layer is actually will provide to you APIs. Okay, so API means application programming interface, some function directly. You need to know that function names. You can directly use that function name and pass the data, and that API will be passed to the device driver, and your function will be performed by the device driver. But you no need to do any information about this device drivers. Okay, so you only know the APIs that this hardware abstract layer contains. Okay, so like generic hardware abstraction aim for independence from specific hardware, close to hardware but more abstract than driver level. Okay, so here this is upper from the device driver layer. Okay, generic defined function. So function is already defined in this function, and you need to just pass the value or pass the parameters argument in that functions, and your work will be done with the help of this. So if you remember this HAL UART init, so this is the only one call. Okay, how what internal operations are performing by this call, that is actually you no need to do. So but you just need to call this, all initialization will happen by the device driver. So this is the one layer actually, which is hiding the internal information. Because of that, we say that hardware abstraction layer. So this is hiding the information of hardware. So this is one, and top of that, we have operating system. So this operating system will interact to this HAL, this hardware abstract layer, to interact with the hardware. And sometimes also this operating system can also directly interact with the hardware. This is not the compulsory requirement for this operating system, but for the functionality, most of the time this operating system will use this HAL, and then it will all operation will be performed by this intermediate layer. So resource control provide standard APIs. So this API to interact with the resource built on top of HAL for the portability. So this is the that structure. Okay. Now next, move to the key concept for RTOS task. So now here, what is the meaning of task now? So task is an independent unit of execution. So sometimes we can say that if any we are performing some operations, we are running one application, and at the specific time application is performing some specific operation. So that specific operation we can say that that is the task. Okay. So that unit of execution, or sometimes we also get that if we are writing the code, that function which we define for a specific purpose, so that we can also say that that is the task. Okay, so this is the independent unit of execution which is not dependent on the another task. So this is the task, and sometimes we also call as a thread for this task. Okay, so on text or registers stacks, this is also required for this at, when we are performing task by the our when we are performing these tasks on the system. Okay, on maybe embedded system or general purpose system. And there are some states for each task. Okay, different operational states. So our task actually go through these states. So we create a task first. So first state is when we are creating the task. After that, that task will be ready for the execution. Okay, so that will be ready. After that, it will be passed to the processor. So that state will be considered as a running. If any resource is required to complete any task, so and that resource is not available, so in that case your task will be moved to the blocked state. Okay, and suppose if any interrupt is occurred, so at that time your task will be suspended. Okay, so this is some that I think is some image is given. Let me check. Yeah, this one. Okay, yeah, please ask, open your mic and ask everybody if someone raised the hand.
Sir,
Yes, Muthu.
sir, if it's okay, shall we do the questions and discuss the concept side by side?
Questions of practice assignment you are
Sorry,
saying?
the concept. Um, yeah, yes, sir. Practice and grader. I mean, you might have prepared some questions for the practice, right?
No, I have not prepared any additional questions, so I can
Uh,
just discuss the same practice assignment or maybe graded assignment if you want.
yeah, sure, sir. I mean, it's. I mean, if we discuss the concept from the question, it will
Okay.
be better to connect the dots like that.
Okay, okay. You are saying that we can just use the question, and meanwhile we
Yeah,
can discuss the
and go
topic.
to the concept from the question like that.
Okay, so yeah, we can do this also. So is it fine for everyone? Okay. Okay, so we can also do this. So I hope you have already watched this video. So let me move to this questions. Week 9. Yeah, week 9 is there. Practice assignment. This is the, yeah, opened. Okay, so this is the first question we have. What is the primary purpose of a device driver in a computer system? Okay, so we have just discussed this. The device driver, what is the purpose? Okay, so here to manage memory allocation. So device driver purpose is not the memory allocation. So okay, memory allocation purpose is this is performed by the operating system, and to provide a high level interface for interacting with hardware. Okay, so this is looking correct, because purpose of the device driver is to interact with the hardware directly. Okay, and this is the high level interface. So that means memory, that register level interaction, memory based interaction, or directly. And to execute user applications, no, this is also not a primary purpose for this. And to control the power supply, yeah, this is also not a specific that this is device driver purpose. So this second option is correct for this.
Sir,
Yes.
uh, so what the third option, what might be the question for which the third option will be the answer?
To execute user applications, so execution is happen by the processor. Okay, so not this device driver just a interface to interact with the hardware. This is not the purpose of the device driver. We can see that to execute the user applications, so that is the operation of operating system first, then operating system hand that pass to this task to the processor. Okay, so that execute user application is the mainly we can say that this is the task of the operating system. Okay, user application, and or we can
Yeah.
say that the processor is executing this.
Yes. Sir, even the user applications is some kind of a high level interface, right?
User application is the main full application.
Yes.
Okay, and to control the power supply, definitely this is not the
Yeah, yes. Yes.
purpose. Okay, next question is the given the following free RTOS code, the Arduino project. Okay, so this code is discussed I think in the lecture also. So what is the purpose of the vtask delay function in the task? So here okay, so this is the example of scheduler. And scheduler means scheduling is also a one task of the operating system. When the suppose if you are performing two tasks and you want to perform the both tasks that in the concurrent manner. So concurrent manner means if you have one processor and you want to perform both tasks in the concurrent manner, that means for some specific time one task will be performed, after that second task will be performed. So the concurrency actually managed by the in this way. So that means concurrency doesn't matter here that both tasks will be performed at the same time. Here for that processor will give some time for some specific time for the task 1, then task 2, then again task 1, like this. Okay, so in this way that all operation happen actually very in the very less time. Okay, in the nanosecond or microsecond some place you will so user will not feel that your task is running that sequentially. Okay, user will be feel that tasks are running parallelly. So same the example is scheduler is giving that scheduler means how the tasks are scheduled actually. So which task will perform, then if that task is completed, then another task will be performed. So uh, that operating system, this is the actually main task of the operating system. So and this is the one example of the scheduler. So here what this example is doing, here we have created two tasks, so task 1 and task 2. Okay, and after that this task start scheduler we have called, so this will manage these tasks. So here when we this task 1 will be start. Okay, so that means we are printing this task 1 message. After that we that this second line. Okay, so this v task delay, it will provide some delay actually. So in between what scheduler will do, scheduler will perform the second task during this delay. When this task 1 delays happen at in between, that scheduler will perform task 2. Same time, after printing this task 2 message by the task 2, then next message is delay for this task 2. In between, that scheduler will just perform this task 1. Okay, so that operation will be performed like this. So task 1, then task 2. Okay, so that this is now switching, we can say that here execution is happening in the switching manner. So that is managed by this scheduler. So here the main purpose of this task delay is for just providing some delay, or we can say that we are suspend the task for some specific time. Okay, so if you see the options to create a new task, so this is not the purpose of this v task delay. Okay, so the created task is happening by this x task create this function. To set a timer for the task, so this is also here we are not setting the time, and here we are actually uh, suspending also. This task will be suspend for some time. Okay, this is a one function. This is a one function, and this is now executing. So this function will stop because this loop is running infinitely. You can see this loop is running infinitely. Task one loop. So that should be run continuously. Okay, but what happened when this delay is coming, so that this function is actually suspended for some time, and another function is executing. So the third option here, to suspend the task for a specified time. Okay, and to stop the scheduler. So this is not the task. We are not stopping the scheduler here. Scheduler are doing their work. That's it, changing the execution to one task to another. Okay, so this third option is correct for this code. Now next
Sir,
is, yes.
in this example, the rate of printing of task 2 is double the rate of printing of task 1, right?
Sorry, what you're saying, rate of,
Printing of task 2 is double
yes,
the
yes,
rate.
double, yeah.
Okay.
Here the delay is less.
Yes. And so, what's this 4 tick period MS? That's
What 4 pick?
a 4 tick period MS. VTask delay after the forward slash.
Forward select. This things.
Yeah.
Okay.
Yes.
Yeah, this is some specific time we are giving. Actually, we are dividing this for 500 for some that specific time we can set this. So what actually, in the respect of the physical, that clock time, we can set this.
Mm. Yeah. Yes.
Okay, so we
Yes.
can take some value, and we can change the ratio of the time based on this.
Okay. Yes.
Which of the following task state indicate that task is waiting for an external event or resource before it can continue execution? Okay, so following task state that a task is waiting for an external event or resource. Okay, yeah, so this is about the state. So as I mentioned that just in the previous example, so after creation of the task, that task moves to the ready state. Okay, and ready, if processor is available to execute, then this task will be moved to the running state. And if any resource, that means if resource is required, or if any that external event is required to complete by that task, so that task actually move to the blocked state. Okay, and if our task is completed, then it will be moved to the terminate state. And another, there is one more state, we have suspend state. So suspend state means if any event is occurred which is more, which have the more priority to execution, so that will perform during that time, our that current task will be suspend. So this is the example, this that means for this third question, this is the blocked is the correct answer for this. Okay, so here
Sir.
task is waiting for the external event or resource before it can continue execution. Yeah.
So, sir. So in case of ready, so how it differs from blocked?
So this is one blocked. Yeah, blocked is the, again. So yeah, after getting the resource, once again this that task will move to the ready state. So ready state is the first state that define that your which task is actually ready for the execution. Okay, so
Okay.
maybe at the some time another task is executing. So after
Oh,
completion of
okay.
the another task, that ready task will be moved to that.
Oh, okay. Yes.
Okay.
So after blocked, ready comes and then
Huh.
running, the last is
Yes.
terminate.
So if you see that slides, I think you will get the idea. Blocked. Okay, so after block, you can see that it is moved to the ready state.
Yeah, sure. Yeah,
Okay,
yes.
then again it is scheduled by the process. So scheduler here, this is the work of the scheduler. So scheduler will pick the task from the ready state and then will move to the running state.
Yeah, yes.
Okay, so next is what type of task is typically triggered by external event, such as interrupt or timers. So here we have different types of tasks. That means okay, so task means uh, if we have a program that will only perform one time. Okay, so that means that will run and finish. And another type we have like forever loop task. Suppose we most of the time in the application of this embedded C, you have seen that we write our code in between the for loop. Okay, so for loop means that code will run continuously. In between, we will just pass some input, and that will read some memory location and it will perform the task like this. Okay, so that type of task comes under this forever loop task. Okay, but some specific tasks, so that event based task. So that means some any external or that event is actually occurred. So this is the is that one time task. We can say that this is not the forever task. So this is the one time task, and that is based on the some based on some event. Okay, event, or we can say that some interrupt. Okay, that task will be performed if any event is occurred or any interrupt is occurred. Okay, so that is called as a event based task. Run once and exit. So this is just a given if you have a program and that task is this is not a this is basically the similar to the event based task, but this is not occur with at the time of interrupt or event. Okay, it will be directly it will run one times like the initialization. Okay, so that in initialization, that part happen only one time in the code. When we run the code, that initialization happen only one time, and after that our code will move to the loop part. Okay, so that this means run once and exit the task. So that task will be performed only once time, and background task like this that will run in the background of the any task. So this is the case of the multiple tasks when we are when our embedded system is performing running one task, and in the background it is checking something like this. So here our question is, what type of task is typically triggered by external event such as interrupt or timer? So that is the event based task actually. Okay,
Yes, sir.
next is in the context of RTOS, what does determinism means? Okay, so determinism means here we can predict the time in bit. So in between, we will get our response back. Okay, so that means ability to run multiple tasks simultaneously. So no, this is not the correct related to this. Efficient memory management, this is also not related to this. Highest CPU utilization, this is also not, and predictable timing behavior of task. Okay, so this RTOS totally that this is the primary purpose of this. Our task should be completed in within the time and predict time. Okay, so that is the meaning of determinism here. So this last option is the correct answer for this. And yeah, this is some example. So you can see in the slide. So which of the following is not an example of the commercial RTOS? Okay, so that I have also checked this in the slide. So you can see some are discussed, I think, in the RTOS. Yeah, this one. Commercial, some examples are given. Okay, and open source. So you can see this JFR is the open source. So I think this option is given in the JFR. Yeah, others are coming in the that same commercial RTOS. So you can,
Sir.
yes.
So can we expect these kind of questions also in term, as this is not a technical question, but general knowledge based question?
Maybe very few question, maybe one two question. Generally, not we are not expecting this type of questions, but maybe one two question you can expect. So just go through once
Yeah,
all
yeah,
this.
sure.
Okay.
Yeah, sure, sir.
What is the function of a hardware abstraction layer (HAL) in an operating system? So to directly control hardware resource without any okay. So what is the function actually for this HAL? Okay, so to directly control hardware resource without any abstraction. So this is not the this is just a reverse. Okay, this is not the
Yes.
purpose. To provide a generic hardware abstraction to achieve independence from specific hardware. So yeah, this is correct. Okay, to enhance graphical user interface functionality, not related, not relevant. Okay, to manage high level application tasks. So this is also not too much relevant for this high level application tasks. So this is not a task for this HCL basically. So option two is correct for this. Which of the following statement about semaphore Yeah, so semaphore is just a variable that manage the communications or some this resource management. When suppose some tasks are using some specific memory locations or some specific resource, so how that will be provided to that resource will be provided to that task. So that actually managed by the semaphores, and with the help of some counter. Okay, so that counter variables like this. Okay, so that means if tasks are that so how many process we have, how many resource we have, so based on that this count value will be decided, some limit value will be decided to the semaphore. And if any task consume any that resource, so that count will be moved incremented. If any task release any resource, so that count will be decremented. Okay, so based on that what that resource management will be performed with the help of this semaphore. So which of the following statement about semaphore is true? Semaphore can only be used single threaded application, so this is not correct. Semaphore can be in the uh, used to count multiple instance of a resource. Yeah, so this is actually the main purpose of semaphores. This count the multiple instance of the resource. So how many resource that actually are that held by some process. So that actually the main purpose of the semaphore. Semaphore are only used with signaling between tasks. No, this is also not the purpose. Semaphore are the same as mutex. So this is not the true. Mutex is just a binary variable that actually we can say that if we change this value to one, that means that that will resource will be locked. That another task cannot be acquire that. If we release the resource, so that value will be become zero. So like this. Okay, so zero one like lock and unlock, this type of situation. So this is also is the same. We can say that this is also one different types of handled of this resource management. But here semaphore or mutex are different things. So the second option is correct for this. Which of the
Sir,
yes,
Mutex comes under semaphores, is it, sir, or not?
uh, mutex comes under, yeah, we can say that.
Okay. Yeah, yes.
Hmm,
Yeah, yes.
okay, but both are not exact same. Okay.
Yeah, yes, sir. Fourth option is not correct.
So which of the following best describe the function of an interrupt service routine ISR in an R2OS? Okay. So handle long running task. Okay. Provide immediate response to the external and schedule task for execution, and manage memory allocation. Okay. Definitely last is not the option. Schedule task is also not the correct. Provide immediate response to external event. Yeah, this is the correct one. So what is the purpose of that ISR? So ISR actually handle the interrupts. Okay. So and this is one, we can say this is one hardware that actually handle the all interrupts by the events. So that provide immediate response to the external event. We can say that handle long running tasks. This is also not relevant. So second option is the correct for this. In the context of an RTOS, what is the primary role of a timer? Okay, so timer, we can say that to generate periodic interrupt for task scheduling, to manage memory allocation, this is definitely not correct. To handle device driver interface, this is also not correct. To increase the priority of running tasks, this is also not correct. So first option is correct. The generating periodic interrupt for task scheduling. Periodic. Okay, so periodic means after some interval. So that interval can be defined by the timer. Okay, so sometimes we also used for the delay. If we want to perform some delay, so we can also use of the timer here. So this option one is the correct for this. Okay, so this is the practice assignment. Graded assignment do you want to discuss? Because this generally we not discuss the grading assignment all in the lab sessions. If you have any doubt in any specific questions in the graded assignment, then we can clear.
Uh, yeah, no, sir. I mean,
Okay, so I'm opening the questions. So let all answer are available in this page. So if you have any specific doubt in any question, so that we can discuss. Otherwise. Can move.
Yes, sir, maybe
Record.
we first cover practice.
Hmm. Okay, let's move to the second Big Ten practice. Okay, so how does the use of interrupts benefit CPU efficiently in embedded system? Okay, so okay, just tell us which one is the correct according to you.
Second one,
Okay, so how does the use of interrupts benefit CPU efficiency in embedded? Okay, so this question is about the efficiency, and I think okay, a Big Ten is all about the efficiency. Okay, so yeah, keep the benefit CPU. Okay, keep the CPU continuously active. No, this is not correct. Okay, and allow the CPU to perform other tasks or sleep. Okay. Uh, how does the use of interrupt benefit CPU efficiency in embedded? Okay, other task. Okay, yeah, so interrupt means interrupt we can receive for some specific task, so that at that time, yeah, if our CPU is continuously running something, okay, so if our CPU is continuously running, so that task will be stopped at that time, and it will perform the another task. Okay, so this is first option is correct. And sometimes if our that CPU is not performing any task, okay, at that time we can pass the interrupt that for the sleep mode, to going into the sleep mode. So at that time CPU will just stop all the task and will move to the sleep mode, and it will save the power. Okay, so that is the benefit of the interrupt for the CPU efficiency. Yeah, we can, this is the correct one. Increase complexity of the code, no. Ensure deterministic timing, this is also not the purpose of this. Okay, yeah, so second option is correct. Which situation is an example where interrupt should be used, be used instead of polling? Okay, so I hope you know the concept of polling, that, and interrupt. Polling is
yeah,
basically if we are running our code continuously like this. Okay, so that our loop is running continuously, and we are checking some state, so that is actually polling. And interrupt is different, so that we are, so any that we will receive, that the processor will receive some signal, and based on that it will perform some another task. So that is actually interrupt we have. So where we actually this where what is asking, which situation is an example where interrupt should be used instead of polling? Okay, yeah, logging temperature sensor at a regular interval. Okay, so regular interval, checking battery level periodically, update a display periodically, motion sensor detection. So motion sensor to detect intrusion. Okay, yeah. So interrupt is, so here if any task is performed in some interval, so that at that time we can say that polling is better, because polling is will continuously checking, will check, and it will perform the task. But if any task is performed at any specific movement, or that event, it is not at a specific time, so we at that time we can use the interrupt. Okay, so that motion sensor to detect intrusion. So that means, so this motion will not be performed in particular time interval, so that means it will perform some specific after some specific time when someone is moved, some motion is happening actually. So at that time if any motion is detected, then this interrupt will be occurred. So interrupt is the good for this last option. Okay, motion sensor to detect intrusion. Consider the following pseudocode using polling to read data from a buffer. Consider the following. Okay, so this one is good. Rewrite this code using an interrupt based approach for better efficiency. Okay. Hmm. So what code is doing? So while code is running, true. If data available, then read data. So this is the example of pooling. Okay, when we are continuously checking if data is available, then read data. Okay, this condition will continuously check. So now this is written. So which code is now interrupt based approach for this? So ISR. Okay, so first thing, second, this option mean while loop is running, if data is available, read, this is not correct. Second is not correct. And ISR data interrupt, perform other tasks or sleep. Uh, this is third option is also not looking correct. Hmm. Yeah, so first option are looking correct. ISR data interrupt. Okay, and read data. So that means ISR will receive a signal. At that time, this function will be called and this operation will be performed. ISR data interrupt. Otherwise, second option is definitely not correct. We are not using ISR service here. And third option is there, but inside this, we are not reading the task. Okay, reading the data. And last option is also a same. If data available, okay, so inside the main loop, if we are checking the condition, read data. Otherwise, while true, enable data interrupt. So this is also here another while loop is running. So this loop will run continuously. So here this first option is correct for this. Okay. So this function will be called by the ISR directly, and at that time, this another function will be actually suspend. Okay. So how does the CPU interact with DMA to initiate a data transfer? So okay, DMA to initiate a data transfer. The CPU continuously monitor the transfer. No, the CPU configure the DMA with start address, length, and destination address. Okay, the CPU transfer data directly. No, CPU perform computation during the transfer. 1 second. How does the CPU interact with DMA? Okay, okay. So initiate the data transfer. Okay, so this DMA we have already seen this concept. This is another actually like a master. We can say that. So we have one CPU master, and with the CPU we also used one another master for the data transfer purpose basically. Okay, so that is called as a DMA, direct memory access. So here actually if CPU interact with, okay, so if any data transfer is required by, okay, and CPU received this information, so that CPU configure the DMA actually at that time with start address, what is the starting address of the data, length of the data, and the destination of the data. So it will this message will be passed to the DMA. After that, DMA will handle all this data transfer. Okay, and during at that time, CPU will perform another task. Okay, so this second option is correct for this. And this is the interaction between CPU and DMA to initiate the data transfer. How can the CPU be efficiently utilized for optimizing power while DMA transfer is in progress? So yeah, this is okay. So by running the DMA inside an ISR, okay, this is also how can the CPU be efficiently utilized for optimizing power while a DMA transfer is in progress? Okay, so by running the DMA inside an ISR, so this is not the answer. By continuously pooling the DMA status, so this is also not saving any power. And by entering deep sleep or low power mode and waking up on DMA interrupt. Okay, yeah, this is looking correct. By performing data transfer directly, this is also not looking correct. So here this third option, by entering deep sleep if there is no another task, or if and low power mode. Okay, so that CPU will move to in this mode, either completely deep sleep or low power mode, and it will wait for the waking interrupt by the DMA. Once the DMA will finish their task, data transfer task. Okay, it will save the power. Which of the following factor increase dynamic power consumptions? Lower frequency, no. uh, Power consumption, dynamic power consumption, so that means that is depends on the okay, for the factor increase dynamic power. Okay, yeah. This fewer transition, yeah, this is also dependency, but here this is saying a fewer transistors. So if we are using fewer transistors, so that will reduce the power actually, not increase the power. But here reduce activity, this will also reduce the power. Lower frequency, that means we are using less pulse, so that will also reduce the power. So higher frequency is the correct answer for this. Higher frequency means we are using higher pulse to the CPU, and this will take more power to generate the higher frequency. So all these are actually characteristics when it consume the power. So if we are using a high number of transistor and gates, so that also takes power to just that increasing the voltage from 0 to VCC or VDD and down. So all transistor actually charge and then discharge, like all these operations is performs. So if you are using fewer transistor means that will this power will be consumed less. So here this is the only correct third option, to increase the dynamic power consumption. Okay, so this question is how would you estimate the power consumption of MCU? It operates 50 milliwatt 20% at of the time and 1 milliwatt for the 80% of the time. Okay, so this is a straightforward question. So that means this is now active time, we can say that, for the MCU, and this is now or we can sleep time or like this. Okay, so this is like a duty cycle, we can say that. So simply multiply this 50 into this 20 and 80 into 1 and add this. So you will get a answer for this. I hope this is clear.
Yes, sir.
Okay.
10.8.
1 and 8, yeah, 10.8, correct. Which technique can be used for CPU optimization in embedded system? Okay, CPU optimization. Using bubble sort for sorting large data set, minimizing the use of CPU, minimize the use of fixed point arithmetic, loop unrolling to enhance performance, increase the memory size. Okay, CPU optimization. So this first is definitely not correct because bubble sort algorithm takes more time for the
Yeah.
large data set. Okay, n square is the complexity for that. So that is definitely not correct. Minimize the use of fixed point arithmetic. And this last of is also not correct, increasing the memory size. A loop unrolling is to enhance performance, this is one correct. But the second option we have also seen, minimize the use of fixed point arithmetic. Okay,
Yeah,
fixed
we
point
have to
arithmetic,
max.
oh no, no, this is fine, this is fine. Fixed point arithmetic means we will use a that fixed number instead of the that floating point value like this. So
Yes.
okay, and this third option is the more relevant correct answer for this. Which method involve the CPU repeatedly checking the status of a condition in an embedded system? Polling. Okay, so repeatedly
Yeah.
checking this. Yeah, this we have already. What happened then? The CPU access data from the cache instead of the main memory. What happened when the CPU access data from the cache instead of the main memory? The data transfer speed decreases. No. Yeah, so cache is the one memory in between the main memory and other CPU registers. So if any data is frequently coming to the CPU, so that data is actually saved for some time in the cache memory. So if after that, if that data is now again required, so that data will directly access from the cache memory. So it will increase the time. So this the data transfer speed decreases. So this is definitely not correct, and the CPU and DMA cannot operate simultaneously. This is not uh, okay. this is not looking relevant for this, because with this question, the bus remains free for the DMA to use. Okay, okay, yeah, this is now correct option for this. Yeah, correct. When we are talking about the DMA, so yeah, this is one specific benefits for this. If CPU is directly accessing the data from cache memory, so that means it is not communicating to the that data bus from the main memory. At during that time, DMA can use that bus. Okay, so this is a correct option. So the bus remains free for the DMA to use. The DMA controller get disabled. So this is also not correct. So third option is the correct that answer for this question number 10. Okay. So in this week we have discussed this optimization thing. So that algorithm optimization, other efficient embedded system. Yeah. Any question from the graded assignments in this week? If you have doubt, or let's move to the week 11. Okay, so yeah, week 11 is basically for debug testing, this profiling and static analyze. Okay, these things. Okay, okay. Now let's comes to the questions. So, in the context of debugging embedded system, what is the main advantage of using breakpoints? Okay, so debugging means we are correcting the code. Okay, correct. This means here we are correcting the code. That means the code have some error or logical error or something else. So, and we want to correct the code. So that is called as a debugging. We are fixing some bugs. So here, this is the breakpoint. So breakpoints is used when we want to check the execution step by steps after the breakpoints. Okay, so here breakpoints allow the program to be execute faster. So no, this is not correct, because breakpoint is actually used to stop the code at that point. It stop the execution at that point. So breakpoint enable the program to run without interruption. So this is also not relevant and correct. Breakpoints let the programmer inspect the state of the program at a specific point. Yeah, this is correct. Breakpoint automatically fix bugs in that program. Yeah, so third option is correct for this. Breakpoints lets the programmer inspect the state of the program at a specific point. State of the program means we can check at that point what the state of the program, that means what if we are using some variable, so what the current value of the each variable we can check at that point. Memory locations we can check. Okay, so that we can check every states of our variables data. We can trace the data in each variables at that point. Okay, so yeah, third option is correct for this. You are a debugging. You are debugging an embedded system controlling a robotic arm. After adding several print statements to track the arm's position, you notice that arm moves more slowly and erratically. What is the most likely cause for this? Okay, so yeah, this is one a drawback of this print statement inclusion. So actually, suppose if for the debugging purpose, this is the one way for the debug is in the normal way we can say that. What we can do, time to time we can insert the print statement for, and we can check the values for the our variables. Okay, but this print is also a one function. Okay, and which is defined in some libraries. So that takes some times also. Okay, that takes some time for the execution. If we use lots of this print statement in our code, and definitely it will reduce the execution. That means it will also take consume some time. So it will reduce the that it will reduce the speed of execution. So check the options. The print statements are causing memory leaks. Not relevant. Not correct. The print statement are consuming too much CPU time, affecting the real time performance. Yeah, this is correct. The print statement are not properly formatted, so this is not correct. The print statements are causing conflicts with the robotic arms motor driver. So this is also not relevant, because print statement is not affecting to the robotic arms any specific operation, but it is taking time for the execution of print statement. Okay, So it is consuming the time of CPU time only. So because of that, the it is affecting the uh, overall time. So second option is correct for this. So how does profiling differs from debugging? Okay, so profiling is actually the analyze the code at the running time. Okay, so this actually analyze basically at the running time the code, or debugging is the correct the code basically. Focusing on preventing the concern runtime behavior, profiling deals with compilation. Okay. So first option is profiling focus on syntax error. No, syntax. This is not the task for profiling. We have the another operation for that syntax. That is also not the syntax error. While debugging fix the performance issue. No, debugging is the concern with the runtime behavior of the program. No, while profiling deal with the compilation. This is also not correct. Profiling analyze performance while debugging focus on the fixing error. Yeah, this third option is correct, because profiling just analyze the performance. So performance means when our program is running, so that runtime. So this is debugging is done after profiling, so this is also not correct.
Sir,
Yes.
so even debugging fix errors during runtime, sir.
And debugging is actually the purpose is totally different.
Okay.
Debugging is the concept to debug the error. Means we are fixing the error, and
Yeah.
profiling is just analyzing the performance of the code.
Yes.
Okay.
So profiling, the result of profiling will be used on debugging.
No. Yeah, debugging, that means same things. Analyze performance analyze means our, suppose if our code, some specific part of the code is taking more time actually. So this is not an error. Okay.
Yes.
Debug is related to the error, some
Hmm.
logical error in some place which actually program is running, but we are not getting output. Correct. So
Yes.
that means we are fixing the error. We are just fixing the bug. So that is actually debugging. This profiling is just a performance checking. So how our code is that performing, speed, memory. Performance means we are checking the time consumption, and we are checking the memory, that how memory consumption is happening by the code. So that types of things we are checking by this at the runtime.
Yes, sir.
Okay. uh, Next is you are developing a video processing application that converts video to different formats. After releasing the first version, you notice that the application takes a long time to process large video files. You decide to use profiling tools to understand the performance issue. Okay, yeah, so this is the purpose. After profiling your application, you discover that a significant amount of time is spent on reading and writing video files to disk. What is the most effective optimization you could implement to improve the application performance? Okay, so what are the option given here? Rewrite the file of input output operation using a different programming language. So this is not too much relevant. Okay, language. Optimize the video compression algorithms to reduce processing time. Video compression algorithm to reduce processing time. And what are the things? Discover the significant amount of time to spend reading and writing video tasks. Okay, and implement a buffering system to minimize disk IO and process data in memory. Input output. Okay, increase the application logging level to track more detailed processing steps. Okay, so in these options, this third option is more close to the answer. Implement a buffering system. So here actually means we are reading the data and writing the data. So that means we require some buffer to reading and writing. So to minimize disk IO and process data in memory. So that means we are minimizing that disk input output and process data in memory. In that way we are implementing our buffer system. Otherwise other options are not uh, closer to the answer. So optimize the video compression algorithms to reduce processing time. Okay, so this video compression After problem after they discover the significant amount of time to spend reading and writing only. Optimization could be implemented to improve the application. This is also one possible that optimization. If we improve our compression algorithm that optimize the video compression algorithms to reduce processing time. So if we compress our algorithm, then we also require the decompression. So that will also actually take increase the time in algorithm this process. But yeah, this is third option is the more closer to this. We can implement our buffer system in that way, so it will minimize the disk input output, reading and writing, and process data in memory.
Sir,
Mm-hmm.
disk IO means
IU means input output when reading writing. Disk reading writing.
okay. The speed. I mean,
Hmm.
does it mean the speed, sir?
Yes, yes, input. So here we are using buffering system. Okay, so we are actually buffering means we are using some memory, and we will continuously read the data. So what happening in the reading and writing process? So suppose we are reading some specific data, and we are waiting for the that writing some things like this reading and read. We are just reading some data, and then that will be processed by our operation. So it is taking time, so that means our operation is happening on the same times. We are reading some data, then processing that data, and we are releasing that memory. Then again we will read some next data. So like this. Okay, if we are not buffering, buffering means here we are continuously reading, okay, and our data is continuously coming in the memory, and that memory have the enough space to store that data. At the same time we are processing the data. Okay,
Oh,
so
okay.
we
Yeah.
have the more memory now.
Yes, sir.
Hmm. Like we can use the queue. Okay, so queue where we can just get the data from the front, and we can insert the data at the last front, last in first out, no, last in first, no, first in first out. Okay, so those data is coming first, that will process first, and we can continuously add more data at the end. So that means reading operation will continuously perform, and it will increase the processing time.
Yeah, yes, sir.
Why is hardware support usually required for insert circuit debugging? Okay, so why is hardware support usually required for insert circuit debugging? Yeah, so that topic is also relevant to the debugging of the hardware to allow the program to run without any interrupt. Mhm. No, to allow the program to run without any interruption. So this is not relevant to the debugging. Okay, so to enable the use of high level programming language, this is also not relevant to this debugging. And to automatically fix error, no, this is also to provide real time interaction with the physical hardware. Okay, yeah, this last option is answer. So why hardware support usually required for in-circuit debugging? So that in-circuit debugging means we are debugging the hardware at the circuit level. Okay, so some JTAG, some tools are there to for this purpose that actually that check the hardware level debugging. Okay, so that means what transistor we are using, what flip flops we are using inside the hardware, that we can also trace the out input or output of that level hardware, that circuits. Okay, so that to provide real time interaction with the physical hardware. So here we are directly interacting to the hardware with the help of this in circuit debugging. So this is the support actually provided by this in circuit debugging. Other options are not relevant for any this debugging, in circuit debugging. And which component is not typically part of the JTAG interface? Yes, so JTAG. Okay, so this TDI, TMS, TDO. Okay, SWDI. Okay, so this is totally different. The tools actually we use for the debugging. So which component is not typically part of the JTAG? Yeah, so this test data in, test mode select, test data out. Yeah, all these are actually the part of the JTAG interface. So if you remember this, if you see the diagram that is discussed in this, so BEAC 11, so you can just remember this JTAG. So you can see JTAG. So TMS for mode selects which device we want to select for this T clock, TDI input, TD output. So these are the that pins we can set, we can communicate through this. So these are the component of this JTAG. Okay, so that serial wire in this serial wire debug is the totally different way to interact with the hardware. So this is not the part of the answer. So this last option is correct. What is one of the main disadvantages? Yes,
Sir, what's the full form of JTAG? I forgot actually.
JTAG. I also don't know. So JTAG is not given. Yeah, I've also not. I don't know right now. So you can just explore in the Google.
Is it joint test action groups? The second
Not sure,
line.
but where it is?
Second line.
Oh, yeah, it is given standard. IEEE standards joint test action group. Okay, yeah, correct this one.
Yeah. Yes.
Yeah,
Yeah.
I also not focused on this.
Yeah. Thank you, sir.
Okay. So next is this. What is one of the main disadvantage of using instrumentation for or profiling? Okay, profiling instrumentation. So let me remember that. What was the instrumentation? That is okay. Yeah, this is strategy. Okay, instrumentation means yeah, we are assigning some clock time at the starting at the end. In between, we are performing our task, some things, and we are just calculating the time for that task. Okay, so profiling means we are just measuring the runtime behavior or that time of consuming by the each part of the code, memory resource constraint, like this type of behavior we are that calculating. And this instrumentation is the one way to check the time using the that some code. Okay, so we are taking the start clock time, and our task is now performing. Then we are checking the end clock time, and then we are reducing this end minus start, so we will get the total time spent by the that particular task. So but if we are using this two additional function, okay, so these are the additional function we have, so it will also take consume some time overhead. So that means now it is relevant to this uh, this one. So inaccuracy due to missed event, high overhead due to added code, inability inability to identify performance bottleneck limited to specific programming language. So this last option is not correct. And this inaccuracy is the disadvantage of the another code. Okay, but yeah, for this question 7 is high overhead due to the added code. So that means if we want to check the time consumed by the each part of the code, so that means for each part we have to add this code: start time, end time, start time, end time. So this will also take some time and will reduce the overall performance of the code. So that means high overhead due to added code, similar to the print statement. So this is the correct answer for this. What is the main function of Valgrind when used in the profiling? Yeah, so this is the another one, sampling Valgrind. Okay, so this is the another tool we have. This memory works help is I have not seen this. Let's see this. What are the options? Optimize code size. What is the main function of the Valgrind? Okay, so optimize code size, generating call graphs. Okay, compiling code for performance, debugging memory and threading issue. Okay, well, all these are actually tools. So some we have to check the specific tasks what we have for this. So dynamic Valgrind dynamic modify resource virtual environment run code and or accept and analyze the code. Memory errors, threading bugs for my so what? Ah, okay, so optimize code size, generating call graphs, compiling. Okay, so this debugging memory and threading issue. Yeah, this is the details given in the slides. Yeah, I am not able to recall this. Yeah, memory error, threading bugs. This is the purpose of the ball green tools. Okay, so you can just recap this. So this is related to this specific tool. And what potential issue can the following code snippet cause, which a static analyze tool might catch? Okay, so we have this another analyzing that things static analysis. We call this. This happens on the compile time, not the runtime. Okay, and it actually checks the code at the compile time and just give the warnings for some specific type of errors. Okay, so like first code is given code buffer 10. We have this buffer size 10, and we are copying some data. This is a long strings. Okay, and we are copying this data into buffer. So what is the possible that this tool our possible cause the tool will catch actually? So here memory leak is the not the correct answer, because memory leak is just a problem of the that dynamic memory allocation if we are doing and we are not freeing it. So that is the one cause. Buffer overflow, yeah, this is one the correct answer for this. Okay, so ninth, yeah, here buffer overflow is the correct answer. And uninitialized variable, no, this is also not true. Null pointer dereference, this is also not true. We are not using any pointer or uninitialized variable. So buffer overflow means we are taking the size 10, but we are copying the long strings which have the more than 10 size. So this is buffer overflow problem. uh
Sir,
yes.
so if there are only 10 characters in the string,
Huh.
the overflow will not
No,
happen, right?
not happen, yeah.
And sir, here the space is also considered a single.
Yes, yes, correct.
Yeah, yes,
Space will also be considered a single character.
yes.
Hmm. So this is the one buffer problems. Another code is also given. This what is the problem in this? So here we are assigning some memory allocation by malloc in str pointer, and we are copying some data. Okay, so here comment is given missing free. Actually, we are not releasing the memory. This okay after using this. So this is the example of memory leak as I discussed in the previous question. So here no initialize variable, no buffer flow, no device division by zero. All these are also a example of this static analysis tool detects. Okay, so all other option are also a that can be detected by this static analysis tool. So this is the last memory leak is the answer for this.
Sir,
Okay, yes.
in the last question, if the string has more than 20 characters,
Then again it
will it
will
be a
both
multiple?
both error. Yeah.
Okay, yes.
Okay, so possible error, I think in the slides, if you see this, like week 11, so there are many example professor have discussed like this. Okay. Static analysis done at the compile time, not the runtime. So this one is memory bugs. Okay, so we are allocating this pointer, but we are not using this and also not freeing this. So both are the there. So that means one is the possibility that we are not using, okay, this pointer in anywhere, and we are also not freeing. So both two problems are there in this. So another is we are using this pointer ptr, but we are not freeing. So this is the memory leak. Buffer overflow is we have discussed. Uninitialized variable like this. Okay, so we have declared this int x, but not initialize any value in this, and we are returning this x. So by default, some random value, we can say that, or garbage value will be passed to this X. So that is one cause of the problem. Types of issue: dead code. So dead code means, here we are calling this function, but this function will always terminate without using this print statement. Okay, so that means if we are checking one condition, if condition is true, we are returning from here, return one. Otherwise, we are returning zero. So that means this code will always complete it with this if else. It will not move to this last statement. So this is the dead code. And resource management issue like this, we are opening the file, but we are not closing the file before after using this. So closing the file is also required, otherwise it maybe create the problem for the resource. Type of issue: potential race condition. So race condition is the another way when, suppose if any global variable is used by different tasks, and suppose if one task is update that reading that global value and updating something, and when one task is reading that particular global value, at the same times what happen, that another task is actually update that value, modified that value. So what happened actually, the first task is actually read the older value, at the same time another task is the updated that value. So now after that, so that means, first task had the older value, now first task will perform the updation in the older value. Suppose this shared variable value have like 0. Okay, and first task is now read this data, at the same time second task is update this data to 0 to 1. Okay, but this is global variable, so this will be read maintained by the all tasks. So and after the first task is increment, already read this as a 0, and now it is incrementing to the 1. But if we see that it should be now 2, because both have incremented, so it should be moved to 2. But what happened, it reads 0, but at the same time another task has incremented. So this behavior is actually called as a race condition, potential race condition. So this is more relevant to the that operating system issues. And yes.
Sir, this example, what's happening in this code? This void star race condition example.
So this example is not actually completely given here, so not thread safe. So this is actually, uh, this is not the complete example, first thing. Okay, so
Oh, okay.
this is one function which is actually incrementing this variable.
Yes.
Similarly, we have the another thread, or this means the same, another task that is also incrementing this variable.
Oh, okay. Yeah.
Okay,
Yes.
but it is, suppose if read this data, at the same time another task increment this data.
Oh, okay.
So
Okay.
what
Yes.
happens, so this have read 0, and now it will increment to 0 to 1.
Yes.
Okay, so it read actually before that update. So the final value now it will move update by the 0 to 1, and the previous that is also updated to the 1. That means two incremented operation have performed, but only value is incremented to 0 to 1. So
Yes.
this is one problem. Null pointer dereference. So yeah, this pointer contain the null. Okay, null means no address, and we are referring this. We are just dereferencing that address because this pointer not contain any address, but we are assigning some value at that address. Okay, to the pointer. So this is the dereferencing null pointer. So this is not the correct. Okay, so our value can be stored at any particular address, not the null address. Okay, so this is called a one problem.
Sir,
Use, yes.
so will it give error or this 10 will be put it into like a trash or something?
Uh, this will not give an error, but this will cause a problem when we will run the code. Actually,
Okay.
okay.
Yes.
But yeah, so this static analyze tool actually will detect this
Okay. Oh, okay. Yes.
as a warning. Yeah, type of use after free. Yeah, so here we have free the pointer, and after that we are using the pointer. So this is also one problem. There is a chance that maybe another program have used that pointer after this free. Okay, so if we have already released the that memory, that we should not use that memory after that, because that memory can be allocated to the another program, so it will create a problem. So this is the one problem. integer overflow. We have assigned some maximum value to the integer, and after that we are incrementing to that one more, so max plus 1. So this is integer overflow. Division by 0, we are dividing any value by 0, so that will create a problem. So these are some common problems which is actually checked by this static analysis tool. Okay, and so this is the it maybe gives some incorrect behavior. This is the warning.
Sir,
Yes.
the integer overflow here int max is it the maximum value an integer can take?
So suppose if we have predefined this maximum value to this.
Okay.
Okay, so that some we have used macros or something, and we have predefined this is the maximum limit for this max.
Okay. Yeah.
Okay, and but later we are what we are doing, we are updating, incrementing this.
Yes.
So these are the possible some examples actually. Okay, other is also possibility we have. So you can see this is one Misra. Actually, this is one organization that actually decide the some rules for the writing the code actually. So here one wrong code is given, like this for loop is given with the colon. So what will happen? This is the very silly mistake, and this code will not give any error. What will happen? This code will run only single time. Okay, and now this x plus equal to I is actually not coming in this for loop block. Okay, this is actually empty loop. This will run completely without executing the lower syntax, this x plus equal to I, and this is actually a mistake. This code is now running empty, and this instruction will execute after this completion of this code. So this Misra, this actually decided that every loop should be written in this way. So okay, so that means body should be written inside the bracket always, not like this syntax behavior, single line statement. Because we in C we can write single line statement for conditional statement, loop statement, all these things. But this is not a good type of code, so we should, for the safety purpose, we should write our code in this way. So this there is a less chance for the error.
Sir,
Yes.
is the above method still being used? I mean, the after the for condition, if we use semicolon.
uh, this will run fine. We can use this type of behavior, but yeah, some place. So this is actually one guidelines for some development by this Misra, actually Motor Industry Software Reliability Association. This is one association that decide actually some guidelines for the development, and this is not for everyone. This is for some, maybe for some specific industry, only for this motor industries. Okay, so
Yes.
this is guideline only for them, but you can use all of this. You can also use this type of code.
Yes.
If you are not using this semicolon after for loop, this code will work fine.
Yes.
Okay. Yeah. So yeah, this is the last question. And Beak 12 is actually all these theoretical things: safety, security, ethics. I also not sure that answer for this. Only five practice assignment question is there. What is the primary goal of safety in embedded system? So safety, security, and ethics. So safety is actually because this embedded system used in many critical operations like medical system, automatic that like driving, like now automatic driving cars, bags, airbags. There are many actually critical equipments are using these embedded systems. So that means safety is also one primary goal for this embedded system. So that means if this system fails, that it our safety should also be maintained actually. If our the system is not working at failed at any point. So there are some example is also discussed by the professor, like that some medical issue happened in the past due to some error, loop unrolling types of error like this. So that means this is now coding actually, all the that some applications are developed by the human. So that means it may be failed at any point for some specific input or a specific situation. So but if it is failing that, it will not cause a like a big actually that safety issue. So that how it can be handled. So some guidelines, some are created for that, some rules are created for that, standard are created for that. So that based on that, this comes under this. So what are the primary goal for safety in embedded system is to prevent system failure, uh, no and to ensure optimal systems performance, to operate a system without causing unacceptable risk, to reduce system development cost. Okay. So here safety means this option C, to operate a system without causing unacceptable risk actually. Okay, so this is the more relevant answer for the safety actually. Here we are not preventing the system failure. That means system may be failed, but if system fails, that there's no risk could be happen actually for the where we are actually using that systems. Okay, so like suppose if we are using in the hospitals and some medical equipment are using this embedded system, so that means if our system is failed, so that means our patients should not be affected too much by this like this. Okay, so this is one primary goal. Why is are the safety standards important in embedded system development? Yeah, so to ensure product compliance with regulations, to provide systematic approach to safety design, to facilitate. Yeah, all are looking correct for this. All of the above. And which of the following is a risk
Sir,
Yes.
in for the second one, the system answer is option A.
Sorry. One second. Why is are the safety standard important in embedded system development? Okay, to ensure product compliance and regulation, provide a systematic approach to safety design, to facilitate interoperability between systems. Okay, yeah, this is not looking correct. Yeah, but second one is looking correct. Systematic approach, safety design.
Yes, I do think all of the above might be the correct answer.
Safety standard to facilitate interoperate. Yeah, this is not looking much relevant, but yes, first and
Yeah,
second.
first
Okay.
two, I mean,
Mm,
second is also very much likely to be answer as much as the first one.
to ensure product compliance and regulation. What is the correct answer given?
System answer is first one, sir. But option,
This one.
all of the above seems to be a correct one.
Okay, okay. Then we will check this. Right now, I am so not sure. But yeah, this to facilitate interoperability between system. This is not much relevant for the safety standards.
Yes,
But yes, to provide a systematic approach for safety design.
at
This
least
is
first
looking.
two is very much
Mhm.
relevant.
Okay, we will check this question. Okay, and
Yes, yes.
can skip this. Which of the following is a risk mitigation technique used in embedded system? Redundancy, yeah, this is correct. Fail safe design, yeah, this is correct. Watchdog time, yeah, all are correct for this. All of the above. Yeah, all these are actually the risk mitigation, how we can reduce the risk actually. So for the embedded system, so that we can redundancy and fail safe design is also watchdog timer is also one of that point is for that. Let me just open that slice. Not this one, peak 12. Uh, yeah, you can see that this is the key points for redundancy, fail-safe system, watchdog timers, graceful gradation, error detection and correction. All these are the points. And what was that question actually? That let me check that also. Is the safety standard important for the system design development? Safety standard, interoperability. This one is also there. Yeah, correct.
Yes.
Easy of testing, validation, system design approach. Yeah, looking all answer are correct. Okay, I'll check this and will update.
Yeah, sure, sir.
And which of the following is not the core principle of information security? Yeah, this is security is the another thing. Yeah, confidentiality. Yeah, this is required. Integrity is also required. Availability is also required. Accuracy is not correct. This for this one principle. Security means our data should not be leaked. Okay, and not be shared. And also, if our data should be available if required. So all these are the primary key points for this. But accuracy is not the point. Security. What is the primary goal of encryption in embedded systems? So this is also comes under the security. So ensuring data integrity, protecting data confidentiality, preventing system failure. This is definitely not correct. Last, enhancing system performance. This is also not correct.
Sir, here also first two seems.
Oh, encryption in embedded system. Embedded system failure. This should not. So what is the answer?
Option 3, sir. Preventing system fail.
No, no, this is definitely not correct. Encryption is totally different things.
Or is it the opposite? I mean, is the question
What
made
is the
to
primary goal? Encryption in embedded
what is
system.
not the primary goal, sir?
This may be. Let me check. Encryption is given. Encryption means we are just encrypting the data.
Yeah,
So
sir.
uh,
Making it
this is
unavailable
the
for
key
us.
asset confidentiality, integrity, availability, authentication, or authorization. Yeah, this is the one things. But yeah, so where is encryption is given? Entity ensure data to systems are not altered and tampered by the unauthorized entity. That is one. Integrity actually should be the answer because and unauthorized protecting. Yeah, this one. Okay. Encryption of data. At rest when saved that is simply in transit during network copy in memory only. Yeah, encryption this is the main purpose actually. If we are just transferring our data in some network communication, so that means we send our data in the different forms. So if suppose if anyone reads the data, that cannot be understand the data actually. So this is the one advantage of this encryption of data for the security purpose. So, but yeah, definitely that should not be the correct option for this. Yeah, this data integrity or maybe this.
Even second option, yeah, yes.
Second option is looking correct. Protecting data confidentially, yeah. But this should not definitely not correct. Yeah, so the question 5 and 2. Yeah,
Yeah, yes.
those are looking not correct. Okay. But I'll check this and will update me by tomorrow if the
Yeah,
answer
sure.
is different. Okay. These are the practice assignments so we can change. Okay, so these are the five, but yeah, the weightage for the week 12 is less, so maybe you will get one question from the week 12. But another weeks I have the similar 2 3 questions from the every week.
Yes.
Okay. Okay, so yeah, you can just revise the initial week also. The questions will be very similar to your quiz one, quiz two. Okay, then any other another query?
So, sir, likewise, the questions from the program,
Mm-hmm.
like
No, programming questions will not be there.
um, like we are provided with the program and ask from it.
No, 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 no.
Okay.
This type of question will not be there. Pattern will be very similar to your that quiz one, quiz two. This is center based exam, and
Yes.
you will get the similar type of pattern.
Yeah, yes.
Okay. Yeah. Okay. So I hope we can close the session.
Yeah, yes.
Okay, then thanks everyone.
Yeah, yes. Thank you, sir.
Yeah, all the best. Yeah, Pravanjan, you're
Yeah,
asking.
yeah, I'm saying just bye. Good night.
Good night, good night. Yeah, okay, thanks.
Yes. Thank you, sir. Good night, sir.
Good night.